This video is about using concentric circles to create an ellipse. So what we have here is two circles. We have our major auxiliary circle and our minor auxiliary circle. These are the two most important parts to creating this ellipse. So what we do is we draw a line out from center, out at any angle at all, to the major auxiliary circle. Then what we do is we draw from the point that intersects our major auxiliary circle, we draw a line parallel to the y-axis, which is this line here, BD, right? Draw that parallel to the y-axis, and then where this line that we have drawn out to the major auxiliary, where that cuts the minor auxiliary, we draw a line horizontal or perpendicular to the y-axis or x-axis, sorry, perpendicular to the x-axis, where these two lines intersect creates the point D. Now if you see here, CBD is a right angle triangle, and as I move the point B around with traces on there, and as I move the point B around here along the circle, you notice that it remains a right angle triangle right up to the point where it is straight there, where B is vertical or in line with the x-axis or the y-axis, sorry, and where B is in line with the x-axis. So you notice that this stays right angle triangle. It even stays the same over this side. It's just reversed and opposite. It's an axial symmetry. It's an axial symmetry of itself, but or it's a mirror of it. It's a mirror image of itself. So when we turn on trace and press play, we can see here that it follows around. This method also works to draw an ellipse vertically. The only difference is when you're drawing the ellipse vertically, what we do is, I'll just pause it now, yeah. What we do is we draw it out the same, only instead when we draw this line out from the center to the major auxiliary circle, we go from our point on the major auxiliary circle, we go parallel to the x-axis instead, and then we go from where the line cuts the minor auxiliary circle, we go parallel to the y-axis, and the right angle triangle is reversed. While you can see here it's up and across, while here in the same quarter it's down and across. So when we turn on trace here and press play, we can see that the ellipse is created as the point N here rotates around, follows the minor or the major auxiliary circle, while the point O follows the minor auxiliary circle, and the point P remains because the vertical line, this line remains parallel to the y-axis the whole time, and N to P remains horizontal or remains parallel to the x-axis all the time.